Urgent alert! Antarctica's ice fortress is collapsing at an unprecedented pace, and every corner of the globe will feel the aftermath for centuries to come. But here's where it gets controversial. Some experts now suggest we might need large-scale geoengineering fixes to halt this meltdown. Are we ready to gamble with such untested solutions? And this is the part most people miss: the shifts deep under the Southern Ocean. In currents that circulate heat and carbon around the planet are faltering, and that could trigger domino effects we never signed up for. Antarctica has long carried a reputation as Earth's most remote and unchanging wilderness, an icy realm beyond human reach. Yet in recent years, field teams, including several of our own researchers, have witnessed a startling transformation. Sea ice is shrinking faster than at any time in recorded history. Massive ice shelves that once floated serenely are thinning and collapsing. Enormous ice sheets blanketing the land are being nudged toward critical tipping points. Meanwhile, ocean currents that function like giant conveyor belts, distributing warmth and absorbing carbon dioxide, are losing strength. Our new study, published today in Nature, makes it clear. These abrupt changes are not theoretical or decades away. They're already here, and unless we act swiftly, they will intensify drastically. What exactly counts as an abrupt change? Scientists use this term when an environmental shift happens far faster than predicted, so rapidly that natural systems can adjust, and the effects feed on themselves. Picture melting sea ice. Less reflective white surface means darker water absorbs more solar energy, which accelerates melting even further. Once this feedback loop begins, reversing it on any human timescale becomes a monumental challenge. Sea ice loss may sound like a localized issue, but it triggers a cascade of problems. Since 2014, the area of sea ice surrounding Antarctica has been shrinking at roughly twice the rate seen in the Arctic. This decline lies well outside the range of natural ups and downs recorded over centuries. Less sea ice also means habitats for emperor penguins and countless other species are vanishing, and once stable breeding grounds are collapsing under warmer, more unpredictable conditions. At the same time, ice shelves that would normally slow the flow of land-based glaciers now stand exposed to open ocean waves, hastening the collapse of colossal ice cliffs. Beneath the surface, the Antarctic overturning circulation, often called the Southern Ocean's heartbeat, is showing signs of weakness. This deep current system sinks cold, salty water and pulls warmer, carbon-rich water from the depths, helping to lock away carbon dioxide and distribute heat globally. A similar system in the North Atlantic has alarmed scientists for years, but the southern counterpart may be changing even faster. A slowdown here could reduce the ocean's capacity to absorb oxygen and lock away greenhouse gases, while also starving surface ecosystems of vital nutrients that normally upwell from the deep. The ripple effects on marine food chains and global climate patterns could be profound. Meanwhile, the great ice sheets on the continent itself are shedding mass at an alarming rate. Regions of West Antarctica and parts of East Antarctica have accelerated their ice loss sixfold since the 1990s. To put this in perspective, if the entire West Antarctic ice sheet were to collapse, global sea levels could rise by more than 5 meters, even without additional warming. Researchers warn we may be approaching a threshold beyond which that ice sheet could inexorably slide into the ocean, although that full collapse might still take centuries or millennia. Yet the possibility alone introduces a major wildcard into every projection of future sea level rise. Today, more than 750 million people live in low-lying coastal zones vulnerable to just a fraction of a meter of sea level increase. As shorelines retreat and storm surges become more destructive, communities from Bangladesh to Miami will face displacement, infrastructure damage, and economic hardship. Who stands to suffer most? Often, it is those who contributed least to greenhouse gas emissions, raising uncomfortable questions about fairness and global responsibility. It's not only ice and water at risk. Antarctica's living systems, both above and below the waves, are experiencing sudden shifts. Warming waters and erratic ice cover disrupt the breeding and feeding cycles of penguins, seals, and countless invertebrates. Pollution and invasive species introduced by human activity add further stress to ecosystems adapted to near-freezing temperatures and centuries of stability. While the Antarctic Treaty and newly designated marine protected areas offer a framework for conservation, these measures alone won't stop the underlying drivers of change. To secure a future for iconic species like emperor penguins and leopard seals, we need concerted global action on greenhouse gas emissions. So which path lies ahead? Antarctica was long viewed as a symbol of planet-wide steadiness. Now, it stands as a stark reminder that when we pump heat-trapping gases into the atmosphere unchecked, environments can shift with such velocity that our predictions and preparations lag dangerously behind. The only reliable way to avoid even swifter, more severe changes is to cut emissions aggressively, aiming to keep global warming as close to 1.5 degrees Celsius above pre-industrial levels as we can. Even if we manage that, much change is already locked in. Governments, businesses, and communities must brace for a future where abrupt alterations in polar regions ripple across every continent. What happens in Antarctica won't stay in Antarctica. The stakes could not be higher. Will we collectively choose near-term economic interests over long-term planetary health? Should we invest more in cutting-edge research or focus our efforts on slashing emissions now? Does geoengineering offer a credible lifeline, or is it too risky a gamble? Share your thoughts below. Do you agree with the aggressive action scientists are demanding, or do you see a different way forward? The discussion starts here.